a todos, muy buenos días. Gracias a quienes pudieron asistir acá presencial y a todos los que nos están acompañando por nuestra transmisión online. Esta es nuestra segunda sesión de los Inria Chile Talks y hoy día nos acompaña Esteban Villalobos, quien es ingeniero matemático y magíster en computación de la Universidad Católica acá en Chile y que actualmente está terminando su doctorado en la Universidad de Toulouse en Francia. Hoy nos presenta su charla titulada Desarrollando un marco de análisis de datos para entender el comportamiento temporal de estudiantes. Sin más preámbulo, por favor, démosle la bienvenida a Esteban y recordarles que esta charla va a ser en inglés. Muchas gracias.
Thanks for the introduction. Just to present a bit about myself. As you just heard, my name is Esteban Villalobos. I'm a PhD student at the University of Toulouse, more particularly in the Computer Science Institute of Toulouse, and even more particularly with the talent research team, which focuses on technology-enhanced learning and basically how to use technology, data, AI to try to help students as much as we can. My trajectory started in mathematical engineering in the Universidad Católica, followed by a master in computer science in the same university. And here around 2020, I started working as a data scientist in Open Green Road, which, if you have never heard of it, is a Chilean edtech, meaning they work for educational technology. And they created a page that maybe you have heard of, which is puntajenacional.cl, which helps students prepare for the admission exam from Chile. Basically, here, 2020, we know what happened around this year. The pandemic hit, so they started to get a lot of influx in their website. And they wanted a data scientist to make sense of all the data that was being generated. And working with this company, looking at the opportunities with the data, is what sparked an interest in working more closely in trying to see how can we use data systems, how can we use data science to help students and try to understand the behavior and how can we improve their learning. So realizing there were many open questions in this field is that I decided to start a PhD in this topic. And I found this lab in Toulouse, which gave me an opportunity to continue this thesis, which I'm about to finish in June of this year, at the end of June of this year. So you will see a bit of some insights I have gained throughout my PhD in how can we use data to understand learners. So a bit of the motivation. Take a look at this image. We can see many students all being subject to the same class, but nonetheless, we can still think that each student that arrives here will follow a different trajectory. Each one will be applying their own ways of trying to learn. They will manage the information that is given to them differently. So we can try to think, how can we understand students' learning? And can we do it in a data-driven way? Recently, and there has been a search in blended learning. Blended learning is just a way to say that we're combining traditional face-to-face, the traditional face-to-face that comes from old times, with more online activities, more online instruction. And clearly this has become a lot more popular since the pandemic. Since the pandemic, we became more comfortable with online systems, which in turn gave a lot of boost to this blended learning technology. These changes, this inclusion of technology, has meant that the students have to constantly adapt to new environments, not even across semesters, but even in the same class, they have to be constantly adapting how they study. And we have seen evidence, a lot of evidence, that students that are effective at self-regulated their learning, meaning that they are able to adapt constantly to new contexts, have more chances of being successful. For the same reason, the UNESCO said that self-regulation is a crucial ability to learn in the 21st century. So now we want to understand, okay, so how can we understand how students are regulating their learning? How can we support this process? And we have a great opportunity that now, since we have blended learning technologies, we have an abundance of data of how students are behaving in the courses. We just have to go to the online systems. Probably you're familiar with some systems like Canvas, Moodle, all these things that the universities are doing to manage how they give the learning to the students. And we can take all the behaviors from there to try to understand what the students are doing. But there's a challenge. How do we make sense of this data? We have a bunch of clicks. We have a bunch of just interactions. But trying to extract this knowledge is a challenge unto itself. So here is where learning analytics comes to play, which is an emerging field which tries to understand and optimize learning using big data analysis techniques. And this is an interdisciplinary field which combines computer science, data science, with educational theories, cognitive science, and sociology. So the idea is, how can we make a conversation across these different fields in order to derive insights from the students? Now I'm going to talk about the specific challenges that I was looking at in my thesis. We have a student. How has been educational research being conducted in the past, let's say, the traditional way of how to conduct educational research? We extract some personal characteristics. These personal characteristics may be, for example, giving them a questionnaire to understand their self-regulation, motivation, their emotions towards the course, or their prior knowledge. This is something that we take one test at the beginning, for example, of the course, and then the course happens. We don't know what the student did, and we have a final grade. Traditionally, the objective was to see if these personal characteristics that we measured at the beginning of the course predicts their final grade. Now we have a promise. We have the promise of data that we are gaining we're recollecting the trace data of the students throughout the course. And we want to understand, okay, can we characterize the behavior of the students using the data? And can this give us some insights about their final grade? This is the first challenge. The second challenge is, okay, but we were doing things one way and we're changing these things. So maybe, for example, these personal characteristics at the beginning of the course, they may be confounding the interaction of how they interact in the course and their final grade. So the second challenge, how much information are we actually gaining looking at the data? Is this data actually being meaningful, and can we extract things that we could not understand before? And finally, what is also common that we want to do is that we want to help students. So for example, we have the course starts. At the beginning, we want to intervene. We want to try to do a treatment. And we will get, ideally, a change in behavior, a change in final grade. So this, again, brings another challenge, which is how can we measure the effect of educational interventions? Moreover, because here we can see in this web of arrows, in this network of how the variables are being connected, that things about the personal characteristics of students, for example, their motivation, their self-regulation, may be confounding their behavior, their final grade, but also if they are participating in the intervention. Some motivated student may be more prone to adopting an intervention than the other ones. And we may say, for example, let's do A/B testing, let's do a treatment and control. This is particularly hard to do in education because we can always have, we can give the tool to have the students, but they may still choose to use it or not. And also there are some ethical dilemmas here where usually if we want to help students and we think that intervention may help students, what is commonly agreed to is that we have to give the opportunity to all the students. We don't want some students to have a more opportunity to succeed in the course than other ones. So for this reason, ethically in education is frowned upon to do some A/B testing and treatment and control. So we need to find other ways to estimate these effects. So I'm going to talk about here about one instance of this study that we were performing, where we collected data from 3 higher educational courses, a total of 267 students. The courses followed different instructional designs, but what they have all in common is that they all had one intervention that we were performing in the course, which is that we gave them Know My Progress, which is a dashboard tool which reflects some aspects about the student learning. For example, they give them information about how are you performing compared to your, in terms of what resources you have to look at, how much time you were explaining the course compared to what the teacher was expecting that you were going to spend. So we give them some tools for time management, planning, and self-evaluation. What all these courses have in common is that the course started, a few weeks passed, and we gave the Know My Progress tool in the middle of the course. So we wanted to see the effects of giving the tool to the students if this changes something in the behavior. So we also collected from the online platform, which was Moodle, some actions which were coded in the following way. Basically, we tried to give meaning to the clicks that they were doing in terms of they were accessing a resource on time, because this is a weekly course. They were expected to see the resources the week that they were posted. So if they access a resource in the corresponding week that is looking at the resource on time, if the week goes by, they don't look at the resource, and the next or the following weeks, they catch up with what they had to do. This is a catching up event. And if they are reviewing something, if they are going again to look at something that they had already seen, this is again a reviewing action. And we have some actions also according to the interaction with the tool. We also wanted to give some more meaning in these courses, because a difference between some studies that have been conducted in completely online settings is that here we have a blended setting, meaning that they are going to the class, they are doing stuff in the class. So we wanted to say, okay, are we doing stuff right before the class, meaning 24 hours before the face-to-face class, right after the class, or during the class? Or are they doing something completely away from the face-to-face class, which we call the self-initiated study? Meaning by their own initiative, they're trying to do something not motivated because the class is going to be in a couple of hours. So let's go to the first challenge, how to characterize a student's behavior. And we'll start looking at some related work. First of all, here that a movement, a trend that we have seen in learning analytics is that we look at learning as a temporal process. A temporal process because students are constantly adapting their strategies, they're constantly changing their environments and what they find is the best to do. So we want to understand how learning unveils over time. And there have been many analytical approaches to handle this. For example, process mining, sequence mining, and epistemic network analysis are one of the most famous ones. And here I will present more things in line of the sequence analysis perspective. But overall, all the types of analysis that we can do can be characterized in variable-centered, which means trying to find features, variables, meaning characterizing the student's behavior in one data point, and finding connections between these variables, meaning we characterize some aspects about the student's behavior, and we see if this is correlated with final grade, is correlated with their personal characteristics, but in a variable-centered way. And the other way is a person-centered way. Person-centered is called when we're trying to find subpopulations of students inside a course. For example, we're not taking into account that we're not going to consider that all students are drawn from the same distribution. We're going to try to find different types of students or different types of trajectories in the data set. Second thing that we have to look at. Another trend is that we have been looking at in learning analytics fields we have been analyzing learning as a latent process. A latent process is that the real learning that's going on is not being observed, because we can never observe the actual underlying process of how they're learning. We only see the results of this process, which is the learning actions that they take in the platform. Basically, the students are having some cognitive process, they are processing information in some way in their mind, but what we see is the manifestation of this, which manifests in the end in an observable process, which is how they perform the actions. And we focus also on given study sessions, meaning let's think about it as a bunch of time that the students spend in the platform, and then they do nothing in the platform for a long time, and then they go back to do stuff in the platform. So this is how the temporal latent process occurs. We have some process of how the learning is unveiling over time. This is the first study session, the second study session, the third study session. We do not observe this process. We observe the probabilities of applying our learning action at different points in time. So we are assuming here that the learning occurs as a hidden Markov model. Our approach, what we did here to advance this line of work, well, first we expanded a bit the hidden Markov model that was being applied. We are using a Poisson and multivariate hidden Markov model. And in the end, this hidden Markov model could be later expanded to include other template models. But here we're limited to the Poisson and multivariate. Then we're taking the tactics, the unobserved process that we estimated with the hidden Markov model, and we want to try to characterize the course level trajectories. Here we're using the person-centered approach, so we want to find types of students, types of subpopulation of clusters of students. And we're characterizing it by using the tactic and when the tactic occurred. So for session 1, they used tactic 2 before the class. Session 2, they were using tactic 2 during the class. And session 3, they were using tactic 1 after the class. So to find the subpopulations, we compared 2 different students, and we used a similarity-based edit distance, meaning how many things do I have to change from this sequence to arrive to this other sequence optimally. And with this, we can create a distance measure of how different these 2 types of behavior were. Using this, and then using a hierarchical clustering approach, we can find clusters of students across different courses. Our results, well, the first insight that we got is that the tactic usage was not homogeneous across courses. We detected 11 different tactics that were being detected with the hidden Markov model. And as we can see, the distribution of what tactics are being applied in the course, in each course, is very non-homogeneous. So this course was very diverse in the types of tactics that people were using. But here, people were mainly using a tactic that mainly consisting at going on time with the resources. So this course, people were following very on time everything and just doing that, and a bit maybe of like reviewing. But here they were using many more things of like catching up, reviewing more, and more combinations of actions. Another insight is that even looking at the same course, the distribution of tactics was not homogeneous across time. So for example, we see that at the beginning of the course, some tactics were having more prevalence than at the end of the course. Overall, looking at the strategies, we found one strategy, one type of trajectory that we call the superficial strategy, because they were having low engagement, mainly following resources on time, but not doing many things. And they were mainly working during the face-to-face sessions. And we found 3 strategies that we call the deep strategies. So this is during the course, they were being highly engaged, mixing tactics together, so they were having a more complex behavior. Another insight that we got is that the surface strategy appeared in all 3 courses, meaning that people that were following surface approaches behaved more or less the same across different courses. But people following deep strategies were mainly course specific. So we found things that these strategies were less shared across different courses. And going to the first challenge, we want to understand how these relationships are how is this course level strategy related to the personal characteristics? The personal characteristics we extracted from a questionnaire, trying to understand their motivation, their self-regulation, and we also used their GPA. GPA, PPA is their accumulation of grades until before start of the course. And what we saw is that for the superficial strategy, it was also correlated with people that had low self-reported self-regulation across all courses. So meaning in all courses, people that self-reported being less self-regulated also manifested this self-reported characteristic during in the trace data. So this was the first insight that we draw in this study. And it's also aligned with prior results in the literature. Another thing that we saw is that this strategy was only related to the course performance in one course, meaning that even though we saw that the self-reported data was influencing the trajectory that they followed in the course, this trajectory was not very related to how they performed in the course. So people can do different things, but still be successful in their way. Which some researchers have found this too, and they have put into question how much are we really getting by looking at the data from the students, from the different clicks that they're performing. Which brings us to challenge number 2. How much information are we really gaining from trace data? Looking at the related works, results in general have been inconsistent, meaning in some courses, some variables are really good predictors, and we take it to another course, and they're awful predictors. But more or less what we see consistently is that features related to the regularity of study, for example, the entropy of their session length and their number of actions per session, tends to be more helpful than looking at the level of activity, meaning the number of active days on the number of active sessions. But also, a recent insight is that looking at how much variance is explained across different courses, people have found that students' unobserved personal characteristics, meaning that they use methods to try to quantify how much variance is related to the student itself, accounts for a significantly more amount of variance than looking at the trace data about what the students were doing. So a way to look at this insight is a good student is a good student across different courses, in that it doesn't matter what they're doing in the class. Or at least doesn't matter what we're detecting in the online systems. So what did we do in our approach? First, we introduced 2 new categories of indicators. First was complexity of behavior, where we take the tactics that we extracted with the hidden Markov model, and we calculate the turbulence and the diversity of tactics. So the turbulence, for example, is here we have a student that's doing tactic A, B, B, other one doing A, B, A, B. And we can see that student 2 was more turbulent because he was changing more frequently in their behavior. Also, we look at quality of behavior. So for example, we have a student that was high risk, low risk, low risk. Another one that's right in the reverse, low risk, high risk, high risk. And we can say that student 2 has a less desirable trajectory because he went from a low risk, he was doing fine in the course, and suddenly something happened and he went to high risk, he's in danger of failing the course. Whereas student 1 studied very badly, but then he went to a very good state, so he finished more strongly. So we wanted to quantify more or less this type of behavior. Again, trying to propose indicators that capture this temporal evolution, not just aggregating the whole course, but looking at how the evolution unveiled over the course. So we wanted to compare these different sets of indicators. Our results, we found significant correlations between behavioral data and their final grades for level of activity, regularity of study, and quality of behavior. The results were, again, not consistent across different courses, but in all courses, we found at least some indicators that were predicting the final grade. However, we found no significant correlations after controlling for personal characteristics, meaning that these personal characteristics, again, the questionnaires, the GPA, they are accounting for more variance than the behavioral data that we're collecting. So we are not explaining new variance when looking at this behavior data. All this variance was explained by the personal characteristics. So, well, maybe there are personal characteristics that are acting through the trace data. Imagine a person arrives with their motivation. They are going to perform some things different in the course, and they're going to get then a different final grade. So we want you to perform a mediation analysis. The mediation analysis looks at an independent variable, the effect that they have on a dependent variable, And it asks, okay, can this effect be explained through the actions through a mediation? So here we have, for example, the personal characteristics, their GPA, their self-regulation. Here we have the trace data, what they perform in the course, and we want to see if we can explain this relationship through what happened through the trace data. And we found that partially we can. I mean, the results again were not consistent across courses, but in all courses we found that this relationship, personal characteristics, the effect that they have a final grade, was mediated, at least in part, with what they did in the course. So what does this say? It says that people arrive with their personal characteristics. This influences what they do in the course, and this relationship is what turns out to make the difference in final grade. But this is partially mediated. This was never totally mediated, so there's still a bunch of variants that we're not explaining. And finally, we wanted to see for challenge number 3, the effect of an intervention, particularly the non-my-progress intervention that we are introducing in the middle of the course. Just as a reminder, this is more or less what we have for the graph. And we have self-selection bias here, because self-selection bias means that we give the tool to the students, and maybe it happens that students that were more motivated, they had more prior knowledge, are also more prone to using the tool. So if we just looked at the effect of intervention on the behavior and final grade after the course, we are really not finding a causal effect that is truthful, because this effect may be caused by some confounder that is explaining both why they use the tool and their final grade. So to control for this, we use inverse probability weighting. The inverse probability weighting is a method for statistical control, where we are trying to measure the probability of being exposed to the treatment, of being exposed to the intervention, and normalizing for this probability basically helps us isolate the causal effect of an intervention when controlling for the things that we think that may be confounders in this relationship. And what do we think is a confounder in this relationship? Their personal characteristics and their behavior prior to the intervention. So for our results, we have that the students that adopted the tool showed more complexity in their behavior, meaning that they're choosing a more diverse set of tactics and they're changing and combining them more after they were introduced to the tool. And this is aligned with some recent work looking at also how students were changing their strategies after they were introduced to different interventions. They find that students that use these support tools have more variety in their tactics after the intervention. But we found no difference in final grade. So again, what this says is we are seeing changes in the behavior, but these changes in behavior are not being reflected in changes in final grade. Before I go to the conclusions, some limitations about my studies. All this that was presented, since these were real courses and being subject to a real intervention, we had small data samples where the goal in the future is to expand this to more varied courses. But what we wanted to see here is, okay, how can we take different types of approaches? How can we see this from different perspectives? What the information that trace data can give us in the course? But in the future work has to expand this work to more courses. Also, the analysis was based on self-reported data and trace data from the learning systems. And we're lacking information on the face-to-face interaction, which could, for example, account for all the variants that we have seen was not accounted for in our methods. But the main takeaways from this talk is that we can use these temporal analysis methods to give us insights about how they're learning, basically how learning is unveiling throughout the course. We can gain some insights. What we saw is that instructional design was highly influential within and across courses because students were constantly changing how they were adapting to the course. And trace data, the data from the learning platforms, is very useful to get an insight, but it has some serious limitations in the sense that we are we can extract some information, but at the level of research, at the level of understanding how this process is unveiling, is probably not giving us more information than looking at the GPA. So in terms of predictors, if you want to predict if a student will be successful, it would probably be more useful to look at the GPA and not do any of this temporal analysis to try to find what the students were doing. But as a way to understand how their learning was unveiling over the course, get some insight, and try to see how different variables are connecting into themselves, we can get some really good insights using this temporal analysis and sequence analysis framework. And thank you for your attention.
Esteban, thank you for your talk. I have two questions. First, how would you model if you would like to, because I understood that you are now trying to explain the behavior of students in certain experiments, right? So how would you model if you would like to predict for a new student what is the right or the most optimal way to study for a certain course, given certain tactics and stuff? So in a way that the model itself can offer you or maybe recommend you certain tactics at certain moments in the course. And the second one is, what do you think about including generative AI in this process, like language models or agents, to try to recommend strategies or tactics for each one of the students, or maybe for tracking, or I don't know. So that's.
I will start with the second one and go back to the first one. We have tried to use the generative models and agents to support this process. We have studied with a few proofs of concepts, but we still don't have enough results to give an answer to this. But this is a very, how to say, rising trend. It's since we have seen all these racing agents, we have seen these new trends come up. So going back to the first question, how can we predict for new students and suggest new paths of analysis? Two things. First, looking at these relationships, whether we saw with personal characteristics, it can be useful, for example, to use these personal characteristics to try to predict which type of trajectory the students will follow throughout the course. What I have seen people do in order to give more actionable feedback is that since you have a hidden Markov model, that the hidden Markov model can measure the trajectories of the students basically at each point in time, you look at which step in time the student is, you look at the probable transitions, and you give more weight basically to the transitions that you think will help the student more in achieve their goals. So with that, you can try to see more or less what was the optimal path that similar people to them were following to arrive at success. And if you combine that with their GPA, with their personal characteristics, you can see if that was also into a factor of the trajectory that they were following. Clearly, here the main problem is for the cold start problem, meaning if they have not done any clicks in the platform, we cannot start predicting their behavior. So here we can use the GPA basically to try to put a prior in what we believe there will be the trajectory. And something I was not able to look at in my thesis is for future work, was using Bayesian approaches exactly for this. It's basically, since we have these personal characteristics, can help us develop a prior of what we think their trajectory will be. And with this, we can more or less estimate, okay, how likely it is. And then when we get the clicks, we can update this prior behavior with the new information that we're gaining. In terms of something that I'm sure your second question was more in line with that too, with using generative AI as a replacement for hidden Markov model, because in the end, hidden Markov model are linear distribution, which we could do with generative AI, we would need much more data that we have access to right now. So here, the problem is not technological, it's more bureaucracy and more practical in terms of trying to access data from a whole institutions, for example. If it could be done, and I think some people are trying to do these movements to get the bunch of data, I think it could give a way to replace the hidden Markov model with something more state-of-the-art, like the transformers architecture. I'm sure if that answers the questions.
So we have some question of online attendance. The first is refers to at the beginning of your presentation, and why do the speaker use HMM? And the other is are other alternative model he could apply?
So here the why we use hidden Markov model, and going back to the reason that what I was mentioning about learning analytics being an interdisciplinary field, is that the hidden Markov model allows us to make the connections to learning theory that allows us to ground our work in existing educational theory, where we conceptualize people as having an internal state that we cannot observe, but this internal state affects what they're doing in the course. So this lends itself very nicely to the latent process of the hidden Markov model. That is the main reason we are using it in this case. Can it be used for, can we change it for other models? Of course we can. We can try, for example, other template models with latent processes to achieve more or less the same result. We can use, for example, if we want to not use the hidden Markov model, we can use other generative approaches, what we were saying before, to try to use information in the past with transformers, for example, looking at different points in time that will affect the future. We can do this with many ways. It's just that also the hidden Markov model is very interpretable. We get results that we can look at, we can analyze, and we can make the connections with instructional design very easily. If we change it for deep learning models, we lose a bit of the interpretability and that hinders our capacity to make these connections with theory. And that is the main challenge in this area when you're dealing with interdisciplinary research, you need to achieve some trade-offs. So we are willing to sacrifice a bit of in the complexity of the model, if that will gain us a lot of interpretability, that we can then collaborate with psychologists and educators to gain insight of what's going on. Okay, so how is entropy and turbulence in this case measured? The turbulence is a measure of, very broadly speaking, how many unique subsequences we can create from the sequence. So for example, if we get a sequence that is just A, just a very simple sequence, we can only create a very small amount of unique subsequences from the data because it's basically A, that's it. If we have more variance in changes, more frequent changes, we can create more amounts of different subsequences from this data, which we conceptualize as being more turbulent. So it's a proportion based on this measure, which also is dependent on the number of transitions that happen from different states, and is normalized according to the length of the sequence. Very broadly speaking, that's the measure for turbulence. And for the entropy, we use the Shannon entropy when it was needed. Every time I said entropy in this talk, it's just the Shannon entropy, looking at, for example, the probability of using an action, or the probability of using a tactic, and taking the entropy of this distribution. So that the predictors. Predictors here, yeah, I was a bit loose with the terminology here. Predictors is basically all that we are using to predict final grade in the case that this is a dependent variable, or in the case of in the last part where we want to predict the changes in behavior, then everything that is used to predict the changes in behavior. Basically, the dependent variables, the independent variables that we're managing to try to predict what is going to go on in the course. On the specific examples where results vary depending on the courses. Okay, so what changes that we saw depending on the courses? Basically, I'm just answer broadly. This was almost everything depending on the context, in the sense of, even though, for example, here we found significant correlations in final grade, for some courses, it was more indicators related to the level of activities in one course and the other ones. Sometimes we saw that level of activity, one indicator related to level of activity was one predictor in one course, but not in the other. And in the other, we had another indicator for level of activity. So this is already one change that we saw. But the main difference we saw comes way back here, which is relation to the different trajectories that students follow in the course. And here is where, for this publication, we made the connections with instructional design, where course number 3 was more inclined for people following things on time, and they were promoting following things on time. As which in the course number 1, they had a group project, they had more activities where they were required to mix up the knowledge that they had get during the course. So there were more pushes to catch up on things if they hadn't seen it, the review for things if they needed to bring up knowledge from the first week of the course at the end of the course, for example. So here's where the main changes we saw are applied. We can see that similar strategies similar tactics can manifest across the courses, but in the way that people are using it is influenced by context.
You mentioned that you use, I don't know if I got it right, hierarchical clustering at some point. Can you tell us a little bit more of the methods that you use and how it went?
So the hierarchical clustering, we use it right here. Basically, we used an agglomerative clustering approach. We took this distance of the students, and here things that went not so well is that depending on some parameters of the edit distance, basically how much weight do we give to the different changes that we can do in the sequences, the dispersion we see in the data is different. So we can see that some more clusters appear in one case than the other ones. And in some cases, we saw that just basically nothing was clustered. In the end, we followed the literature in what they were proposing. And we saw that even though we found four trajectories in the course, there were many outliers, people that were not being able to be clustered in any of these courses. And we disregarded these outliers for the analysis. But it tended to happen that some people were their own cluster and we had to discard them for this general purpose analysis. I think those were the main challenges we found. We follow also the hierarchical clustering because it allows us to have a more graphical way, a more interpretable way of choosing the number of clusters. When we don't know it in advance, we need to be able to cut in terms of how much difference there is between the clusters, and the hierarchical clustering is a nice framework to do this.
Yes, you answered this part of it, but do you think that there is like different behavior, different results for both? I understand now, in part, or in your opinion, part of the attributed part of how the courses were organized.
Mm-hmm.
Does it, they were like very different topics, or
they were all in computer science, slightly different topics. So one was more related to database management, so more SQL things. Another one was more related to Excel and more data managing in that sense, basically. So the topics were different. They were all in the same institution and in computer science. But again, this changes maybe also because of the types of resource that was with the types of things that the student needs to interact with. This may be also a difference in the terms of strategy that they're using.
The idea here is to try to get a global picture of how it works, or you, I mean, you know that it's distinct, the overall picture. What is it to provide suggestions for the student?
No, we had this. At the beginning, we had to see if we incline more towards giving tools to our researchers or developing the tool to ourselves. And due to the constraints of the PhD, we incline more in the analysis, basically looking at what people were proposing and the hypotheses that were posing of why things were or were not working, and that's where we try to explore more. So the limitations of this is that not many people have used this type of tools to give the insights to the students. We tried to do this with very poor results because in the end, trying to make the suggestions for the students, they were not very actionable, meaning that students, either they didn't trust it or they didn't understand why this would be helpful. So what we were proposing as future work is that we need to further our efforts in terms of causal analysis, because in the end, the question when we gave it to students was, okay, but why? Why do I have to do this? And we can say, of course, because we saw that it's more likely that people will arrive this, but if in the end, we need a more robust way to say why this could help, not just because someone else helped it, but how this will help you complete the things or you manage your study. So in order to give feedback to the students, we need a more robust causal framework in order to give this actionable feedback.
I think that
because if you start suggesting students, it automatically becomes unfair, no? Because you're suggesting stuff to people and not to everybody. So maybe it would be more interesting or let's say more fair to find a way of changing the course so the behavior of the students are changed. Otherwise, I don't know. Probably all your suggestions will be study more, no? And they already know that, no? So it's like how to change the engagement of students by forcing them to get into the correct trajectory, no, or the correct behavior. It's just an opinion.
It's exactly one of the insights that we got, is that it has more impact to give these insights to the teachers than to the students, because the teachers are the one that can adapt the course. And this is why we also focus on interventions that a teacher could make. They could introduce new tools, and where we try to develop these frameworks as a way for teachers to understand the changes that happen in their students throughout the course. Because sometimes, especially now in blended learning, where people have to do things at home or at different places, teachers have a very limited picture of what's going on with how students are studying. And this can help shed light on things that were hidden to them before. We think that this is the correct way to go. We think that's going to have more impact. We try to do some things with teachers, but not enough to be published or to show some significant insights on this regard. But yeah, definitely what we have saw is exactly in this line, that it's more useful for teachers to have this information because they have the power to change how the course is organized and how people will engage with the resources.
Okay, thanks for your questions. And Esteban, thanks for your presentation and stay here with us. and the public in the online. Thank you for attending, and see you in another presentation. Thanks.